we make things. We use our hands, minds, and machines to build, to fix, to improve. We're known as do-it-yourselfers, home improvement fans, fix-it fanatics, inventors. At our core, though, we're all makers. So let's jump in and make something.
Hi, I'm Ron Hazelton. Welcome to the show. The oscillating saw was invented for cutting off plaster casts. However, it's evolved into an extraordinarily versatile home improvement tool. The secret to that versatility, though, is in choosing the right blade for the job. Today, we'll see how to do that. Whether it's the winter cold or summer heat, the idea is to keep those climate extremes outside while making the indoors as comfortable as possible. State-of-the-art replacement windows play an important role in doing that. Installing them can even be a do-it-yourself project. We'll see how. Repairing wall damage is not that difficult, but restoring wall texture can be a bit challenging. Today I'll show you a technique that makes that job quite doable. This is an oscillating saw. Fitted with the correct blade, it can cut through wood, sheetrock, concrete board, plastic, metal, and more. The key is to use the right blade or attachment for the job. The oscillating saw was invented over 70 years ago, originally as a device for safely removing plaster casts. Circular saws move in a rotary direction at high speed. Reciprocating saws move back and forth in a linear direction. Oscillating saws alternate direction up to 20,000 times per minute, but move through a very small arc, about 3 degrees. In the case of cast removal, this is what keeps it from cutting skin. The secret to getting the most from an oscillating tool is in using a high-quality blade and matching the blade to the job. These blades, all from Zenith Industries, are manufactured from high-performance alloys and designed to cut specific materials. Each one goes through a microphase hardening process that improves performance and keeps the tool sharper longer. When it comes to cutting wood, this chrome vanadium fast cut blade is top of the line. It features a Japanese-style tooth design with a double row of alternating bevel teeth. It's the best choice for clean, fast cuts in wood. The spacing of the teeth allows for sawdust and small particles to be expelled, greatly reducing any tendency to burn. It's a good choice for plunge cuts in materials like laminate flooring and for cutting door jambs and casings during tile, wood, or laminate flooring installations. The blue oxide coating keeps this blade from leaving marks or stains on the material being cut and protects the blade itself from rusting. This fine-tooth version of the chrome vanadium blade, also with the blue oxide coating, is well suited for plunge cuts in drywall, especially when doing cut-ins for electrical boxes. This extra long blade has cobalt steel teeth and a titanium nitride coating that makes it suitable for cutting bolts, trimming off bent nails that are in awkward, difficult-to-reach places, and cutting pipe when there's not enough space to use conventional plumbing tools. Its long reach also makes it a good choice for cutting through framing nails during demolition. Bimetal blades also have cobalt teeth and are a good choice for cutting through wood that has embedded nails. This blade, too, can be used to separate nailed-together framing members. Semicircular blades made from high-speed steel offer excellent straight-line cutting and can even be used with a straight edge since the teeth have zero offset and don't protrude from the sides of the blade. This is also a good choice for terminating cuts without overcutting into adjacent surfaces. For even more precise cutting, the flat, toothless portion of the blade can be used. Carbide grit blades have no teeth, but instead have tough carbide grit vacuum brazed to their cutting edges. These blades come in a variety of shapes and can be used for dressing cut ceramic tile, chasing cracks when repairing concrete, and shaping cut edges on wood. This diamond grit version excels when it comes to removing tile grout or plunge cutting in concrete board. These blades have no teeth or grit at all. Made of high-grade stainless steel, they feature sharp, knife-like edges and are used for lifting, cutting, and scraping. They're well suited for removing caulks and sealants from around sinks, backsplashes, and tubs, lifting carpet and tile adhesive, scraping loose peeling paint, slicing through caulking before prying off wood trim, removing old silicone sealants, detaching non-slip stair treads, and even cutting carpet. This is often called a multi-function tool. Fitted with the right blade for the task at hand, I think you can see why.
Every month I get a piece of mail that I really don't look forward to receiving. My utility bill. Ouch. Well, one thing that's predictable about my utility costs, and that is that they keep going up every month. And I can't help but think that part of those heating and cooling dollars are going right out my windows. 35 years ago, when this house was built, these windows were standard fare. In those days, energy was cheap. The fact that a single pane of glass was a poor insulator was, well, not that big a deal. Then, heating and cooling costs started climbing. The storm windows that were put on about 20 years ago were supposed to make the house more energy efficient. Quite honestly, I'm not sure how effective they really are. But more importantly, I just don't like the way they look. I also don't like what it takes to clean them. So for all of those reasons, I'm going to replace my old windows. And I'm going to replace them with this, a state-of-the-art double-hung window from Pella. Now, it's got the look that I want. It's very energy efficient, and you won't believe how easy this is to clean. The installation? Surprisingly simple. Step 1 is to remove the storm windows from the inside. Then, start on the frame outside. Now this storm window frame is held in place with several screws around the outside. I want to take it off, and normally what I do is just use a screwdriver and back those screws out. But if you take a look here, you'll see that I've got a problem. These screw heads are covered with several coats of paint. There's no way I'm going to get a screwdriver to engage that. So I'm going to use this little tool right here. It's called a grab-it. On one end is a reamer right here. That'll bore kind of a small hole in the head of the screw. And on this end is the retractor. Let me load this up on the drill and show you how it works. First, I use the reamer to create a cone-shaped depression. Then turn the bit end for end and use the retractor to back out the screw. Back inside, I use a utility knife to cut through the paint and caulk between this narrow strip of molding called a sash stop and the window casing. Then I insert a putty knife and work the sash stops loose enough to allow room for a pry bar. I'm going carefully here because I want to reuse these when I install the new window. With the stops gone, I remove the upper sash, lower sash, and window track all at the same time. This piece of wood, called a parting strip, comes out easily by gripping it with a pair of pliers.
Now, with the exception of the storm window, I've been able to do all of my work from the inside. There's been very little demolition required, just the removal of these 3 strips of molding. The outside trim and the casing right here, still intact.
With the window opening clean, it's time for a test fit. First, I check the sill to make sure it's level. Then apply silicone sealant to the bottom corners. From my van, I get a couple of rolls of aluminum weatherproofing tape. I peel off the protective backing. Then, starting on the sides, press the tape onto the surface and smooth it out with my hands. The tape has a butyl adhesive backing that will prevent any water from penetrating the sill. Next, I apply silicone sealant to the outside stop against which the new window frame will sit, the edge of the window ledge, or stoop as it's called, and the corners at the ends of the sill. Now I can set the window in place, putting the bottom in first, then tipping the frame upright and pushing it against the stops. I check to make sure the frame is square, then begin installing shims. First at the top, then the bottom, and finally the middle. For the window to operate smoothly, it's important that the gap between the sash and frame be uniform top to bottom. With the frame square and locked in position, I run screws into pre-drilled holes in the sides, through the shims, and into the jamb. Then, using a utility knife, I score the shims and break off the excess. There's a small gap or space between the edge of the frame and the window opening that I fill with low expansion foam made just for this purpose. About the last thing I have left to do here on the inside is replace the sash stops I took off earlier. Outside, I begin making a watertight seal between the replacement window frame and the original opening by pressing foam backer rod into the gap between the two. Then I fill the remaining space with silicone caulk. Spray the surface with a lubricant and release liquid called Caulkmate and tool the joint smooth with my finger.
This is a standard window screen, but I'm going to be putting in high transparency window screens. Pella calls them Vivid View. 50% more light, 3 times as much airflow, and great curb appeal. As a matter of fact, it's like having no screen at all.
Even though these windows are state-of-the-art, they still look very conventional. The millwork detailing, classical hardware, and authentic proportions make them seem as if they've always been part of the house.
In fact, they look even better than the original windows because I no longer have to use the storm windows. And the reason I don't have to use the storm windows is because of the way the new windows are constructed. Actually, they're made up of 2 pieces of glass with the space in between filled with argon gas. Now here's how that works.
Older windows typically have a single pane of glass that offers little insulation value. In the winter, warm air passes right through to the outside, wasting energy. In the summer, outside heat penetrates the windows,
driving up air conditioning costs. On the other hand, double insulated glass with a gas-filled barrier reflects warm air back into the house in the winter and keeps heat outside during the summer, lowering heating as well as air conditioning costs. Now, these windows also have a coating on the glass. It's called a low E coating. That filters out damaging ultraviolet rays and helps prevent fading on upholstery, drapes, and carpeting. But you know what I think I like best about these windows is the way they've been designed for easy cleaning. You lift up, push the tabs on the inside, tilt this down, clean the outside of the window. The upper sash works the same way. When you're finished, put it back, and that's it. Good looking, energy efficient, and easy to clean. I mean, what more could you ask for in a window?
If your home was built in the 1960s or later, there's a good chance your walls may have a wall texture. Now, restoring or repairing that texture may seem challenging, but actually, it's easier than you may think. Wall texture is intended to hide wallboard joints and other imperfections. Usually, it's applied with some sort of spray equipment during construction. Frequently, the need to repair or restore wall texture occurs when a section of the wallboard itself has been replaced because of damage or repairs. There are actually several different styles of wall texture, but two of the most popular are knockdown and orange peel. Knockdown involves flattening the peaks left by a spray-on finish, and orange peel resembles the skin texture of this popular citrus fruit. Homax makes an aerosol product for creating both styles. Even though applying wall texture is a fairly straightforward process, there are a number of variables that can come into play. Air pressure, material volume, distance from the nozzle to the wall, and spray pattern can all affect the final appearance. For this reason, the Homax aerosol applicator head has two important adjustments. This one for air pressure, and this one to control the volume of material. The best way to match an existing wall texture is to experiment on a piece of scrap cardboard. Then hold the sample up next to the wall. Orange peel texture is simply sprayed on the wall and left to dry. Knockdown requires a second step, using either a joint knife or this knockdown tool that features a sponge rubber pad attached to the blade. I found this tool easier to use and less likely to leave edge marks. Hold the knockdown tool almost parallel to the surface. Before spraying, hold the aerosol can upside down and shake vigorously to thoroughly mix the contents. I found that holding the can 12 to 16 inches from the wall gave me the best results. The material can be applied in a circular or linear pattern, but what's important is to keep the can in motion at all times. When you're finished, hold the can upside down and pull the trigger to clear the nozzle. After a short wait, usually a minute or less, the knockdown tool is passed over the surface using light pressure. If for any reason you're not pleased with the look, it's very simple to remove the texture and start over. Once the texture dries, it can be painted. So if you're looking for a way to replace damaged or missing wall texture, well, the solution could be right here.
To view today's projects again, visit ronhazelton.com, where you'll find hundreds of how-to videos available 24/7.